We are going to start by referring to the questions that were from factoring expressions. It was yesterday's content. Please write this down as I go through it. We'll start with a few review problems, and then we'll break into some new problems that expand upon your understanding. So the first thing I do is I'm going to use this pink piece of paper that's been provided to you. And I look for 8, and I look for 98, and I don't see either one of them there. So I'm going to hit the smaller of the two numbers, and I'm going to think of all the numbers that nicely divide into that. So the numbers that divide into 8, 1, 8, and 2, and 4. Now we want to factor out the largest possible value. So I start with 8. 98 divided by 8 doesn't work. I need a whole number. 98 divided by 4 doesn't work. 98 divided by 2 will work because it's an even number. So I'm going to factor out here a 2 out of each one of these terms. Factoring out a 2 and using a calculator if it's needed. 8 divided by 2 is 4. 98 divided by 2 is 49. Okay. From this portion, I want to look at the values 4 and 49. 4 is a perfect square. 49 is a perfect square. How do you show your work? 2 times 2, 7 times 7, and we take this exponent, since we're working with squares, and squares we divide it by 2. 2 divided by 2 is 1. The 2's come from the front, so they must remain in front. The 7 and the x's come from the back or behind the symbol, so they're going to remain in back. 1 is positive, 1 is negative. It doesn't matter if you put a plus sign or a minus sign first. The other operation will go into the second parentheses. We're going to look at another problem like this. 225 x squared minus 81. You will be provided with the sheet, so we're going to find 225. Okay, it's a perfect square. Find 81. It's also a perfect square. 225 breaks into 15 and 15. Dividing this by 2, since we're working with perfect squares, 2 divided by 2 is 1. And 81 breaks into 9 and 9. So the 15 and the x's come from the front. The 9's come from the back. 1 is positive and 1 is negative. But what's different about this problem compared to the previous problem is that the 15 and the 9, I'm going to underline those. I recognize that there is a value that divides into 15 and 9 that allows me to reduce it. What is the largest number that you can divide nicely into 9 and you can also divide into 15? 3. So let's put a 3 out front. 3 times 5 is 15, bring down the x. 3 times 3 is 9. So I just factored out a 3 out of the first parentheses. We're going to do the same for the second parentheses. Factoring out a 3 again. 3 times 5 is 15. Bring down the subtraction sign. 3 times 3 is 9. When you write things in factored form, you're just rewriting it in a compressed fashion, but you do need to simplify it as far as possible. This is the act of simplifying further. I'm going to multiply these two constants. So 3 times 3 is 9. And I have 5x plus 3 and 5x minus 3. This is the final answer. Okay, let's look at the next problem. Next problem, please write down example number 3. Again, you can write this down on the back of the packet you were provided today. So I'm going to move this up. Let's go to example number 3, please. Oops, sorry guys, let me grab this. Okay, 27, subtract 192 x squared. $27 is not a perfect square. 192 is also not a perfect square. Does that mean we can't factor it? Well, let's check. The smallest of the two numbers is 27. What numbers divide into 27? 1 and 27, 3 and 9. So grab that calculator. Again, if you don't have one, they're up against the wall. Grab one, please. And I'm going to start by dividing here. 192 divided by the largest factor. Oh, doesn't work. I need to have a nice whole number. 192 divided by 9, 192 divided by 3. I can factor out a 3. So let's put a 3 out front. If you don't have great number skills, then grab a calculator. 27 divided by 3. If you don't know that that is 9, then to divide on your calculator. 192 divided by 3. We just came up with an answer of 64, but if you forgot that, divide on your calculator. Notice that this time is like example number 1, where the x squared is in back. So if I break apart 9, it breaks into 3 and 3. If I break apart 64, it breaks into 8 and 8, and I divide this by 2. Now, I'm going to show you what is incorrect. Please don't write this down. I saw this a lot today. Automatically, they wanted to write the x in front. That's not the order this came in. The order that we are provided this problem says the 3 is going to go in front. So 3's go in front, and the 8x goes in back. 1 is positive, and 1 is negative. So you get to this problem, the very first thing, if you're like, Miss Bradley, I want to be able to do this, but I don't know how to go about rewriting this, because factoring is just a way to rewrite it in condensed form. So I look for 162 and 50. Do I see 162 and 50? So I choose the smaller of the two numbers, and I ask myself, well, what numbers divide nicely into 50? Well, I know 1 and 50 go in, but what other numbers go into 1 and 50? And if you don't know, you're literally going to take the calculator and start dividing, looking for whole numbers. Oh, 2 and 25 go in. And as you check and you try the different ones, you see, oh, 5 and 10 go in. Now, why am I writing those down? Because in order to write this in factor form, you have to write it in the most simplest form. So I start with the larger of the two numbers now, and I'm going to divide by 50. We see it doesn't work. And then I divide by 25, and we can see it doesn't work. It doesn't work because I don't get a whole number result. I take 162, divide it by 10, it doesn't work, and I divide it by 5, it doesn't work, and I keep going, and I realize that 2 is the first number that works. So the number that works is the number that we're going to divide by. So on your calculator, you're going to go 162 divided by 2, that's an 81. So if I distribute 2 times 81 is 162, there's the x squared. Then I'm going to take 50 and divide it by 2 to get 25. Now, if we did this right, hopefully we see 81 and 25. Is 81 a perfect square? Yes. Is 25 a perfect square? Yes. 81 breaks down into 9 and 9, 5 and 5, divide by 2, x and x. So the 9s and the x's come from the front in this problem. They're going to remain in front. The 5 comes from the back. They're going to remain in back. 1 will be addition and 1 will be subtraction. I want to take this out, and I'm just going to choose any symbol. Later on you'll use in math, but we're just going to call this star. So I'm going to write this as 4 stars squared minus 9. Now that looks similar to what we have done to this point. So I look up here and I'm like, oh, we got a 9 and we got a 4. Sweet. 9 breaks into 2 times 2. 9 breaks into 3 times 3. Okay, I split that and I have star and star. Easy enough. And I have subtraction, so I can keep going. So I have 2 stars are in front. Okay, got it. 3's are in back. 1 is positive, 1 is negative. All that is good. But we don't have any stars in this problem. So what does star really equal? Star equals x minus 2. So I'm going to rewrite this. Now, I'm going to take out the star, and what does star equal? It equals x minus 2. And now I can distribute to get 2x minus 4 plus 3. 2x minus 4 minus 3. And my final answer is 2x minus 1 and 2x minus 7. So similar to the last problem, I want to take this portion out. And And later on, you may use something called use substitution in math. Right now, we're going to use something that's not a letter, so it's not a variable that you're used to. Let's use like a star. We could use any symbol that we want. Let's use a star. And I'm going to rewrite this, but instead of putting the expression x plus 1, or that quantity, I'm going to replace it with star. And then I'm going to ask, can I break this apart? So if I'm going to be able to break this apart, a couple things have to occur. 16 and 25 have to be able to be broken down. 4 times 4, that works. 5 times 5, I can divide this by 2, and I have subtraction. Okay, this fits, I can do this. So how do I show my work? This is showing work. 4 times 4, 5 times 5, I break this down into star times star. If you're doing a problem for me that is a quiz or any type of an assessment, and I can see you're breaking apart and I can see the thought process there, I can give you points. If you just show me an answer, and I think you copied from front, I can't see your thought process to get to that point. Okay, at this part, we're going to make our 2 parentheses. The 4s and the stars come from the front, so 4 star, 4 star. The 5s come from the back. A common question I had yesterday is, how do I know if I put a plus sign first or a subtraction first? It doesn't matter, it's up to you, as long as 1 is addition and as 1 is subtraction. Now, in this original expression, was there ever a star? So I'm going to draw an arrow from this parenthesis to each of the stars. That's what I'm going to do next. I'm going to go back and I'm going to replace the stars. Sometimes students ask, how do I know when I use brackets or parentheses? They do the same thing in math. They just allow us to group things. So I'm going to go through, and wherever there would be a star, I'm going to leave a parenthesis. Now, in those open parenthesis spots, I'm going to replace the star with what's really I set star to equal. Star is equal to the quantity x plus 1. Now I'm going to distribute, and when you distribute, you multiply. 4 times x, 4 times 1. Distribute. 4 times x, 4 times 1. And my very last step will be to combine like terms inside each of the brackets. 4x plus 9, 4x minus 1. Every problem we do with difference of squares, that's what we're working on. This has to be subtraction. This has to be subtraction. So what if we cannot rewrite it with subtraction? We write not factorable. Okay, write down the next problem, please, with your partner. Here we go. Okay, so we're going to break 36 into 6 and 6. I'm replacing this quantity with the star, and then I still have star times star, divide this by 2, and then 5 times 5. Okay, so what do I have right now? 2 parentheses. The 6 and the stars coming from the front. 5s come from the end. 1 is positive, 1 is negative. But in this problem, there is no stars. Stars is just something silly that I'm saying in order for us to understand how to break it down further. So what we will do is we are going to go back here, and I'm going to replace the star with what star equals. This is what star equals. It's the quantity x plus 2. Now I'm going to distribute the 6, and I get 6x plus 12 plus 5. Distribute the 6, 6x plus 12 minus 5. Combine like terms. This should be my final answer. Remember, this is just another way to write this, right here, to write this original expression. So this is in factored form or condensed form, and we have up above is an expanded form, and I guess we could expand it even further.